Okay, we're going to do an example with diagonal projectiles. It talks about a golf ball being hit at a speed of 78 meters per second, 23 degrees above the horizontal. Determine the horizontal distance the ball travels until it lands. Assume no air resistance. So just to draw a quick little picture, right, we're playing some golf. We hit that golf ball with the golf club and it goes flying up into the air, and it is then going to travel a certain horizontal distance. And so that's what this question is asking for, is what's that horizontal distance traveled? Now, of course, we know that usually the golf ball will bounce and roll, or if I'm golfing, it hits a tree, but the distance horizontal is what they're asking for. This is often sometimes referred to as the range of the ball. I know that it's not like a mathematical range, which is usually vertical, but that's just what we call it in physics sometimes. It's called the range. Okay, so in approaching this problem, the very first thing I want to do is separate out horizontal from vertical. So what I'm going to do is I'm going to take my vector of 78 meters per second, and I'm going to break it up into its horizontal and vertical parts. And so I've got an initial x velocity and an initial y velocity, and this angle of 23 degrees is above this horizontal distance. So label this side here. This side would be my adjacent side, this would be my opposite side, and that would be my hypotenuse. And so again, I can just use a little bit of trigonometry to define those values. So to get the initial x, all I have to do is take the hypotenuse, 78 meters per second, and multiply by the cosine of 23 degrees. When we do that, we end up with a value, and I'll just record an extra digit here, 71.80 meters per second is that horizontal component. This is a good idea would be to store this value to x on your calculator. The other component, VIY is then the vertical component, and then this would be 78 meters per second. It's on the opposite side, so I use the sine ratio. So I'd go sine of 23 degrees. And so putting that onto the calculator real quick gives us a value that is 30.48. Again, just taking an extra digit here. Also, I would probably store this to y on my calculator. So I've got my components. Now what I can do is think about the x and the y. So I'm going to break this component up, and sometimes we use a t-chart to break this up. So this is my x, this is my y, and I normally kind of go in the same order here. The first thing I realize is acceleration in the x is always 0, and acceleration in the y is always 9.81 meters per second squared downwards. The question is asking me to find the horizontal distance traveled. So I need to know that. The initial x velocity is, as we calculated, 71.8. So 71.80, whoops, meters per second, and the initial y velocity is 30.48 meters per second. This direction is downwards, and that direction is up. Whenever I go to solve a kinematic equation, I always need to know at least 4 variables. So the fourth variable that I would think about in this case is time, but time is an unknown. And on this side here, I also have time because I know the time is the same for both motions. Just like in horizontal projectiles, right? The time is the same in both x and y. And the fourth variable that I would use on the y side is I would use the final velocity. So we know again that when it leaves the ground with an initial velocity, it's going to hit the ground at the same velocity, but just in the negative direction. Because the height is the same, the motion is symmetrical on both sides, and so the up velocity and the down velocity are same, but just opposite. So then I'm going to use then this is the final y velocity, and also put it in as negative 30.8 9.48 meters per second. I kind of jumped the gun there a little bit. This is just down, and we're going to call down negative, and we're going to call up positive. So then I should make this gravitational acceleration negative as well. So, as I said, we always need 4 variables to solve a kinematic problem. So here I have 3 known variables and 1 unknown variable. That's a very solvable kinematic. Here I only have 2 knowns and 2 unknowns, and that makes it extremely tough to solve, if not impossible, unless we find some of the other information. So I'm going to use these 4 variables right here to then come up with a kinematic equation. So the equation that I would probably use is the acceleration formula. I have VF, I have VI, and I wish to know time. And so just rearranging this equation real quick, multiply both sides by time, divide both sides by A. I can then say, okay, the final velocity is a negative 30.48 meters per second. Again, I'm putting that in as a downwards velocity, and then the up velocity is positive. I'm just going to highlight the fact that I'm subtracting a positive value, which is exactly what I'm doing. Now, of course, that's really just the same thing as subtracting, but just to kind of highlight that. And then the acceleration, of course, is a negative downwards acceleration of 9.81 meters per second squared. So I just have to put this onto the calculator and calculate what my time value is, just to take a quick guess. This is about 71, this is about 10, so we're looking at about 7.1 seconds, give or take, maybe a little bit bigger than that, like 7.13. I'll just fire up the calculator here real quick. And so times 2 and, oh, sorry, that was bad math. That's about 61, so about 6 seconds. And then divide by 9.81 to get that value. So I get 6.21. Again, I'm just going to grab another digit here, 6.214 seconds, give or take. And so now that I have the time, I of course can then use that time in this space here, right? I can use it for this here, and I can also use it for that there. And so I now actually have then 4 pieces of information here. And so I now can then solve these 4 variables using some kinematics. So the last little bit then is just to use the velocity. In the horizontal direction, we know that because acceleration is 0, the equation is just the initial velocity multiplied by the time. And so to calculate that displacement, all I have to do is take the 71.8 meters per second and multiply that by the time that we just calculated, about 6.214 seconds. And that'll calculate the displacement for us that we do. So if I just multiply this answer here by 71.8, then I get a value of 446 meters. So that's the distance of this drive, which is approximately 440 yards. Which is a pretty good belt in golf, right? So that's a professional level right there. Okay, so again, the things that we kind of did to solve this problem, the very first thing I did is I drew a picture to calculate the components, right? So calculated the components. Once I had those components, then I broke it up into an X and Y chart, a T chart. Just allows me to organize the information. And then, of course, I then went to my formula sheet and try to solve some problems using some kinematic equations for my formula sheet.